One of the most common questions that beginners ask when they are confronted with Haskell I/O is, how do I get an int out from an IO int? Or equivalently, how do I get a string out from an IO string? Right? So the reason why this happens is quite understandable, because, right, if we look at something like getLine, a function that we have been discussing before, that like blocks and asks the user to enter something and then gives us a string, and you then want to work with the string, and you think you can just work with the string as usual, you might be tempted to do things like getLine ++ foo in order to like append foo to the string that you've just read, and you'll get a type error. And the type error will say, well, look, right, foo is a string or a list of characters. You're using ++ to append two lists. So this thing should be a list of characters as well, but it isn't. So you want a string, but you have an IO string, right? And well, then you ask yourself, okay, if I have an IO string, but I want a string, how do I get a string out of an IO string? So that is how this question arises, right? Similarly, if you have an IO int and you want to multiply the int in some way with some other int, you run into a similar problem. An IO int is not an int, right? So you do get these kind of situations. You have IO actions, you want to get the result out. So I have been hinting at this already, but the answer here is that there is no such function. There is no way to get the string out of an IO string, and that is on purpose, right? Remember, an IO string is standing for a plan, an action that when executed performs interactions with the outside world, right? Performs real side effects, and only based on those can come up with the string. So these interactions are in general really needed in order to obtain the string. There is not just a plain string, right? And so a plain string without IO is something that we can compute in a given context without needing to perform any effects. An IO string is something that we can only compute if we first execute some effects. And that is not something that we can just forget, right? If something depends on reading a file or something like that, then it really depends on reading a file. We cannot just pretend that it does not, right? So that is the reason why there is no such function. However, we can still achieve, and we actually already have achieved, what we want. And the trick is bind. Right? Remember the type of bind. The type of bind is IOA, and then A to IOB, and then B. And here, by saying that the second argument to bind is a function that gets an A when the first argument was an IOA. This is exactly the way that you go from an IOA to an A. Right? You get access to the result of the previous computation if you put two computations into an application of bind. But you only temporarily get access, and that is the key point here, right? Because the second action must again result in an IOB, and the compound action that results from the bind is an IOB again. So overall, we still retain that the whole stuff that we're doing depends on IO, right? But when constructing larger plans, we can pretend that we have access to the results of previous components, and that's exactly what we need to do. So basically, the answer, whenever you're asking yourself, like, how do I go from an IO string to a string, or how do I go from an IO int to an int, the answer is almost always create a sequence of actions, right? Start a do block, or use an explicit invocation of bind, or use some other function that is written in terms of bind, a function such as lift a2, a to b to c to ioa to iob to ioc, or just fmap a to b to ioa to iob. Right? These, to a lesser extent, also give you access to the results of I/O actions. Right? With fmap, you can apply a function that works on an A, and you can apply that to a result of an I/O A. But again, the end result is an I/O action again. With lift A2, you can, if you have two actions, one with result type A and B, you can use an operator that uses both an A and a B, a plain A and a plain B as an input, and combines these, but the end result is an I/O again. That is always the common situation. You cannot really escape from I/O, but you can temporarily escape from I/O, and you can still use functions that operate on these results. Right? So if you want to append foo to getLine, right, you need to do something like getLine bind, and then pick up the result, and then append that to foo, and then return this again, so to make it an I/O action. And then we can read something and get it appended to foo. Or you can recognize that this is just a pattern that corresponds to fmap, so we can do something like this instead, where the dollar operator again is the infix version of fmap, which does exactly the same thing. Okay, so there is no real problem. You just have to train yourself that whenever your reflex may tell you that you need a function of type IOA to A, then what you actually want to use is bind, or some other function that is defined in terms of it. Now, I don't want to lie to you. There is actually such a function, and it's called unsafePerformIO, and it is defined in a module called system IO unsafe, and the type of unsafePerformIO is actually IOA to A. But it's called unsafe for a reason, and basically this is worse, by far worse, than doing something like head and tail or calling partial functions that may crash. This is really, really, really dangerous, and you should not use it. Right? The main reason why this function is in the language is that in rare circumstances, in particular involving interacting with other languages, with other programming languages, say, for example, with C, we want to wrap some code that doesn't actually have observable side effects from the outside, but internally does something that is side affecting, something like it allocates some part of memory, then calls a C function that writes to that memory, then takes the contents of that memory out, and then deallocates that memory again. And if we wrap all these things up, then from the outside there is no observable side effect. So this is usable as a pure function. And in situations such as this, it may occasionally be useful to call something or to have something like unsafePerformIO available to say, we take the responsibility here that from the outside there isn't actually an observable side effect. But that is basically the proof obligation you have. If you use unsafePerformIO ever in a situation where there is a side effect, just to forget about the I/O, you get into really strange situations, right? Really unpredictable or dangerous behavior of your program. And you should really not do it. I'm a Haskell programmer for more than 20 years now, and Okay, so I'm not writing particularly low-level code most of the time, so perhaps other people have similar experiences, but nevertheless, I think I have probably been using unsafePerformIO something like 10 to 15 times throughout the years, not all that much more often, right? So it's something that is more like once per year or once every few years, right? And unless you're really writing some sort of low-level binding to libraries in other programming languages where there may be more frequent use cases for this. But it is a very rare occurrence, and you should understand perfectly well what you're doing. Otherwise, it's best to just forget about it. And as a beginner, I can almost guarantee you that whenever you think you need a function like this, you don't. Right? The proper approach is the one that I explained before. The proper approach is to just use bind, to accept that the type system is right, that if you are depending on I/O, you are actually depending on I/O, and you should not just forget about it. You should not cheat. Right? So stay away from this function, even though you now know that it exists. Right? And if you feel you need something like this, then the answer is most likely bind.